Welcome back everybody, Wolfie speaking, and today we are going to have some fun in fighting. Well, mostly going to reviewing something that I made, probably my best version of Python in my 4 or 5 years of knowing it. As you can see, I've got lots of stuff, especially in random. And gonna say a few things. I changed my name from ColorTech to Wolfie because Wolfie is the name I use everywhere online, and ColorTech was just a relic of the past. Also, probably gonna change the channel focus from Redstone videos to coding and Python because I find it way more interesting. Meanwhile, Redstone just takes way too much time and I get bored. So that's it, and we're going to quickly get on to the focus of the videos. So we're going to be reviewing pretty much a program I made in Python, which is a simple explosion simulation using Pygame as the graphic library. It's my best Python program, I would say, and the one I like the most, and also helped me learn a lot of stuff, especially about optimization. So we're gonna start with usual imports, which is Pygame, which is for graphics, time, used to measure times, make clocks and that stuff. Math, which gives a lot of functions, math like sin and sin and cosine, cosine and sine, and then we got NumPy, which is array, pretty much another math library, but I use it most for the arrays, and we got random, which, as the name implies, creates random numbers. We start with creating a Pygame window and a NumPy array for the pixels. Each individual pixel will have health value, which will be decreased by an explosion, so as to simulate different materials with different explosion resistance. Then we create two arrays, one for explosions and one for the rays that have been cast. Here we generate the screen pretty much. So as you can see, we got the screen in 3 different colors. Each band is from top to bottom stronger. So this dark one is the weakest, this grayish one is the middle strength, and this almost white one is the strongest. As you can see, we got some explosions, and the rays that are cast are in this thing. You can see it does more damage to the almost black, then to the gray, then to the white. Then we got to the main loop, where we've got measuring for time, and we've got temporary pixels array, which just steps for drawing the actual explosion. And so here we handle the explosion. What we do is we take all the variables, so the center, the power, which is how much damage it will do, the time, so over how much time the amount of fragments will be, or rays will be cast, which is, as this variable here says, fragments should be, and then we got pixels, which is and then we set the pixel in the middle to 0, just to make sure that we don't leave pixel, which is one of the bugs in the third version. Then we create an ID for easier management. Then we loop over how many times we've got to create the fragments, and we create to give the starting position, an angle, and then a power, which should be within random, within 1/5 of the actual power, and twice that. Then once the time is 0, equal or minus 0, we pop. So we remove the element from the array. Then we get onto the fragments, which is, as I said before, the arrays that simulate the actual explosion. We take the position, the angle, which is converted into radians, the life, so how much strength it's got left, and then the ID, which again simplifies the array management. Then what we do is Then we add 5 times per frame we do the simulation, so we add moves, pretty much moves by 5 pixels per second. Then we round it down because it still has to get snapped to the pixel array, and then we check that's within bounds of the screen, and we update temporary pixels, we update the life, calculating by subtracting the strength value of the pixel, and we set the pixel to 0 once it gets destroyed. And if that is 0, we remove the element from the array, which means that it stops existing. If the life is positive, so it's above 0, we update the position and the life. Here we detect whether or not the button is pressed. For left mouse button we got explosions, and on right we got can create some walls, but it's bugged, so we never stop. And then we can of course create other explosions. Here is once again for the pressing, for the button handle. This creates the the wall, and then we've got get to the main part, the slowest part, which is the actually drawing to the screen. So for that speed up, we find the temporary pixels, and we get the non-zero values. So we find the position, and this will work with later, and then we just shape the pixels, which is the actual array of all the pixels, into a different array with the same total size, but we can handle better and we can draw faster. So we going for each line. So for each higher part, which will be this 2000, we will check if they're all the same, and if they are all the same, if the pixels are all the same color, we'll draw them all at the same time. If they're not, we will draw them each one by one. Then of course if we get to the end of the line, we go up in Y position. Then we look through all of these, so all the positions in the temporary pixel that have something, so they're non-zero, and we update them, we set them to the window with the pink color, and this is the result. Very simple, slow, and that's pretty much it. So we'll go on to the second revision, which doesn't change much. They change the preset, but that's not important. Doesn't change anything. We improve performance by moving the calculation of the cosine and the sine within the explosion, so we only calculate once per array. So here we're just gonna add the pre-calculated value, and we also we slow it down to get better performance again. So we move it by 4 pixels per frame, and then the rest is the same except for the part where we draw. So we got this drawing function, which actually works, and of course we got the explosions, and you can see the different materials, different strength, pretty much the same thing. Then the big improvement comes into the third version, which instead of drawing pixel by pixel, we just do it all at once with an array, with a screen array. So as you can see, we go the same thing. We just start here, instead of having more complicated logic and code to actually draw to the screen. What we do is we simply take the screen and remove the pixel we want to remove, which makes for a much faster problem. We also speed up because we gain a lot of extra speed from the improved drawing method, and then with a simple update we update the screen, and then we also add a sleep function to slow it down, because it would want to go above 1000 FPS, which isn't necessary, so we limit it at 500. And this is the result. This is not actually the result. This is the result. so you can see much faster, smoother. The frames are better in general. We can replace this in this analyze bigger, which and also the iframe rate helps with making it smoother because it checks more time per frame whether or not it's pressed, and more times is taken per frame, and explosions run better, and yeah, that's pretty much just it. But it runs really better, and that's it. So I hope you like my overview of explosions and stuff. There isn't really much to say. What we could try to do, as I wanted to say, since I always have fun with coding. If you wish to, I don't know, write something in the comment, I could try to make something simple. Of course, I'm not all that good. I would certainly try, and maybe if I can't, I would ask for help. So this has been Wolfie. Today we've explored some Python problems I made, and I am gonna say bye bye to you. See you next time.